Hi everyone, I'm Matthew. Hopefully you've been to a couple of my webinars before by now. Today what we're going to do is have a look at Dimxpert. So that's one of the tools that we've got available to us in SolidWorks, and what that does is allow us to do some 3D geometric tolerancing. Just before we do kick off, I will remind you that these videos will be recorded, and I will remind you that these videos will be recorded, so they'll be available on our website, so you can go back and watch them anytime. So don't bother making notes or anything. Just watch and perhaps enjoy. Okay, so what is geometric dimensioning and tolerancing? Hopefully everyone will be fairly familiar, so I'm not going to go into too much depth on this, so don't worry about that. But it is a way of communicating dimensional and tolerance requirements. So this is what it looks like. You can see on the screen there all the pink dimensions that we've got there. And you'll notice that it's a combination of standard plus minus tolerancing, which is what's also referred to as coordinate tolerancing, plus geometric tolerance, which is what you can see in the box there, which is what's called a feature control frame. And that helps us to further define the feature. Now, what this allows us to do is build in imperfections, so we can make account for or take account of imperfections in, say, manufacturing processes, etc., so that we are still ready for when those imperfections occur. Plus minus tolerancing or coordinate tolerancing alone doesn't really provide geometric characteristics that are important to fit, function, and manufacturing. So, for example, the feature control frame can reveal information about how flat, how straight, how parallel two faces are, etc., etc. So here, for example, we've got a location dimension just here. So it gives us a number of additional information with regards to each of the features that we've got in there. It also provides information about datums and additional tolerances and material conditions, which we'll see in a sec. Today, I must be honest, most designers do tend to just stick with the plus-minus coordinate tolerancing. I'll have a quick discussion on why one is better than the other. So we'll see that in a second. But just so you're aware that these practices are all governed by standards and manuals. So you're probably all familiar with BSI standards or the ISO standards for geometric dimensioning and tolerancing. Okay, so a typical problem that we would solve using geometric dimensioning and tolerancing. So here, what I want to do is measure the big hole in the center of this part. However, there is more than one way to measure this hole location. As you can see, the bottom of the part is uneven, and that may be rough due to casting or because the part was torch cut, for example. The way in which I locate the part on the surface and the way it touches the angle plate will determine how that X dimension is determined. So here you can see I can plonk it down this side and measure X from there, or I can plonk it down this side and measure X from there. The part will obviously touch the surface plate at different high spots depending on how it's oriented with respect to the surface plate and the angle plate. In the example shown, the X dimension will show a slight difference in the measurement between the two methods, and that's because the part sits on different high points, and that tilts the part in slightly different orientations. Now, geometric dimensioning and tolerancing would actually define exactly how the part should be positioned relative to the surface plate, so the guy that's labelled on the bottom here, and the angle plate. And it would also define how the X dimension is measured from the surface plate or the angle plate. So we can specify whether it is in this direction or this direction using a datum. Finally, it would also define the tolerance for the size and position of the hole, as well as possibly some of the information about how straight the hole has to be through the thickness of the part, how perfectly round it has to be, etc. So the important thing here is that 3D geometric tolerancing actually provides critical information which is necessary for manufacturing and also inspection. So once we have manufactured a large number of these, we do need to check that we're getting the right sizes and shapes. So we can use the geometric tolerancing to define the inspection process as well. Okay, so just briefly, you'll notice I am just doing this in PowerPoint. We've had some graphic issues with this. But We've got, on the left-hand side, we've got a standard plus-minus tolerancing coordinate system. We've got a geometric tolerancing on the right-hand side. So you can see here we've just got, say, for example, a symmetric one here. We've got plus-minus 0.25 mil on this 16 millimeter diameter. You can also see we've got that here, but we've also got these geometric feature control boxes in here. Okay, and we will see a bit more of that in a second when I jump over to SolidWorks. But briefly, so this tool is absolutely geared towards designers who require high precision components. Although you might say, well, I want it to be as accurate as you can make it, you still need to take into account the tolerances that have to be built in as a result of manufacturing processes, etc. It's also very good for products that are designed and produced in high volume, so you can have manufacturing flaws that can build up, and if you're not taking that into account, then that manufacturing flaw over a large volume, eventually you'll have some items that are outside required specification. It also allows us to perform a tolerance stack-up analysis, and that is something that's actually built into SolidWorks. The Tolerance Analyst tool, you can add it in, and you can use all of the tolerances that you've placed on all of your parts in an assembly to stack up the tolerances and actually get the variation of one particular dimension based on the tolerances of all the other components, which is a really handy tool, and perhaps we might come back to that in another webinar or something. It's also, yes, primarily geared towards anyone who currently suffers from assembly fit problems as well. So if you're seeing problems in assemblies, that is a result of that stack up, and so one way that we can try and combat that is by geometrically dimensioning and tolerancing our components. So in SolidWorks and, well, everywhere else, you get a number of feature tolerancing symbols. So that's the first box in our feature control frame, and so we can specify, say, our flatness, circularity, etc., etc. So here is a list of all the symbols that we can include in SolidWorks. You'll also see in the next box of the frame we can include, say, the diameter symbol, our tolerance, and we can also put in the symbol for maximum material condition or the least material conditions in there, and we can also reference all of our datums. Okay, so Dimxpert for us solves a huge problem, because when we are coming into dimensioning and tolerancing our components, we have to go through and specify the tolerances for all of the individual things. So say, for example, if you were just designing a part and then tolerancing it in SolidWorks drawings, you'd have to go through and in each of the individual feature control frames add each of the components. But what Dimxpert allows us to do is lightening our way through that by giving us some automatic tools. Also, without Dimxpert, when you are doing it manually, it is quite possible for you to skip or forget a certain item, which might just mean it might not be the end of the world, but it might mean that the drawing has to go back to the drawing office once after it's reached the shop floor, because someone says, well, I don't know what that's meant to be, so then you have to make a change and go back. And that's just additional time, which we can save by using this automated tool. Also, again, finally, Dimxpert is an automated tool, so it ensures that everything will be correct for manufacturing based on your initial setup. And finally, before we do jump over, the targeted part types for the Dimxpert tool are parts that are machined, so we can have turned parts or milled and drilled parts, so prismatic parts that have got fairly straightforward geometry to automatically dimension. Obviously, as it gets more complex, it's very difficult for the automated system to pick up. So we're not gearing it towards sheet metal parts because we're not yet supporting bends. We're also not gearing it towards molded and casted parts because we can't yet support draft. Finally, special geometry, so if we're looking at gears, threads and cams, now that's another quite complex problem, and that's not something that's been added into the Dimxpert functionality just yet, but watch this space, there's always potential. Okay, so let's now jump over to SolidWorks and have a look. So what I've got here is just a very simple part to start off with, and you'll notice that you've probably seen this item a number of times but never used it. In the tabs along the top here, so we've got our configuration manager. Over here we've got our Dimxpert manager. So if I click that, you see we're taken into the Dimxpert environment. It's built into SolidWorks, so there's no real change. Also, one thing that you can add, which will make life easier, is if I right-click on the command manager and come into the Dimxpert item, I can add my Dimxpert toolbar as well. So I'm just going to dock that on the side here for the time being. Okay, so what I'm going to do first of all is manually go around and use the Dimxpert tool to place on some tolerances. So let's start off by placing in a geometric tolerance for the planes that I'm going to use as my datums. So let's first of all grab a plane, and I'm actually going to make that 0.05. Oh. And I'm going to place one on this face just here. And it's done simply by clicking and placing, much like placing dimensions when you are generating your drawings. So I can hit OK, and you see we've got those three geometric tolerances already placed. I can also make these faces datums, so I'm going to use the standard label setup. I'm just going to set this front face as my A datum, so I'm going to click that, and you'll see it automatically snaps to that geometric feature control frame, and I can place that just like that. Next, I'm going to do the same for the bottom, and the same for that side face just there. Alright, so that's my datum setup, so now I can go ahead and start putting on some locations. So using the location dimension item on my toolbar, I'm just going to put on the tolerance for that dimension there. So you hit C there, we've got 10 plus or minus 0.5, and we'll come into how those are set up in a moment. Next, what shall I do? I'll grab the bottom, grab my location, and I'll grab the bottom one and place that just out there. And I'm going to go from my C datum out to one of these legs. You'll also notice that as I do them, the two faces are highlighted. You'll see that I'm missing one of these. So what I'm going to do is grab that face again and again come over here. And so now you'll see we've got two items which are in actual fact the same. So what I can do, if I select one, hold down my control button and select the other, and then right click, I can combine the two dimensions, so now we get 2 times the same one. So we can simplify that up as well, which is really nice. Okay, next I'm going to start coming in and placing in some features. So that's using my feature size dimension option. And for example, I'm going to grab this chamfer and just place that out there, and you'll see that the setup that I've got has already picked up the dimensions of the chamfer and also what tolerance I want to place on each of them. Next, I think what I'll do is grab my hole just there, and you'll see that it knows, because I did it using a hole pattern, it knows that I've got 4 of those which are identical, so it's automatically added that. And now what I'm going to do is add a geometric tolerance to that one. So I'm going to come in and specify a positional geometric tolerance. 0.5 is exactly what I'm after. I'm going to include that diameter, and I want this to be my maximum material condition, like so. So you see it's adding them to the frame already. Next, I'm going to just specify my A, B, and C as my primary, secondary, and tertiary references. And all I need to do is click once on this dimension, and it'll snap it underneath, just like that. So that's my geometric reference, my geometric tolerance feature frame added to that one specific dimension. Another important thing that's really handy when you are doing this is this button here, which unfortunately doesn't have a label underneath it, but if you hover over it, it will tell you it's the show tolerance status. So what I can do is click that, and it's going to highlight all of the features in a color that tells me whether they are fully defined, partially defined, or not even considered yet. So here you'll see everything external of this notch has been fully tolerant, so it's all gone green. Now what I'm going to do is add in a feature tolerance on this notch, and you'll see that it's recognized that it is a notch. Hopefully when I hit OK, you'll see it's recognized that it's a notch. And when I hit the show status again, you'll see that now it's changed to yellow. So it's been partially considered, but we haven't fully defined the tolerance on there yet. You'll also notice that we get something similar in here. So we've got the writing has gone blue, and we've got a negative sign, meaning that it's undefined, or underdefined, sorry. So what I'm going to do is just include a location dimension as well from here to my reference plane B, sorry. And when I hit OK, you'll see that that underdefined is gone, and now everything is all green. So we are good to go with all of our tolerances. Next, I'll draw your attention to the planes that they're added on. You might have seen this annotations folder before. If I expand this, what you'll see is we've got a right and a front plane, and we've got an A next to each of these. And that tells us that we've got annotations attached to those planes. So now what I'm going to do is actually drag this part into a drawing. Any second, there we go. And so I'm going to select a front view, and you'll see over here we've got A's next to my front and right planes again, and that tells me that I've got annotations attached to these. So as I drag that model view in, you'll see I can check this box for import annotations, and I can choose the Dimxpert annotations just here. And what that's going to do is bring in all of those dimensions that I've just been generating using Dimxpert into the drawing. So that's all done. I don't need to recreate those, and it hasn't taken me long at all, and I can do that very, very quickly, very, very easily. I can drag these around just like normal dimensions in a drawing, and I can even grab a projected view if I want to add my right view here, and it will pick out those tolerance dimensions just there as well. Alright, so that is manually setting up our tolerances. So what we're next going to do is have a look at doing it in an automatic environment. So let's jump first of all quickly back to our PowerPoint. So SolidWorks Dimxpert has a great function which essentially allows you to pick specific tolerances for a number of different features, and SolidWorks will recognize those and stick them straight on for you. So here on your screen now we've got a list of all the feature types that we can include. So we've got holes, cones, counterbores, all the way through to chamfers. You'll see it recognized my notch, which was this guy here. And so what SolidWorks will do is when we automatically ask it to dimension up our part, it will recognize all of these features and apply a predefined tolerance to each of those features. So you'll see in a second we access this through the document properties, and so what we can do is specify a method for tolerancing, either a general tolerance or a block tolerance. If we want to use the block tolerance, what we can do is base the tolerance value on the number of decimal places that we've got in our dimensions. So say, for example, on the right hand side here you see we've got our diameter dimension here is to 3 decimal places. So that would use our tolerance 3 in this case. Our length dimension here is to 2 decimal places, so that would use our tolerance 2. Oh, I'll just drag that around. We can also do something similar for our angular dimensions, so we can just place a tolerance on our angular dimensions, and that will be based on one particular tolerance value. And what we can do is instead just use a general tolerance, which will base it all on exactly the same system, so they'll all have the same tolerance value. Okay, setting up our properties, I'll show you the environment in a second, but what you can see we can do here is, say for our diameter, we can say, well, I want all of my diameters to be symmetric, and I want them to have a plus minus 0.1. I want all of my width slots and notches to be symmetric, and I want those to be plus minus 0.4. And so we can set those up in advance so that when we ask SolidWorks to automatically tolerance up our part, then it will do so based on our initial settings. Okay, so let's have a look at the part that I've got here. So I'm going to ignore this toolbar now because I've got my automatic dimension scheme up here. So what I'm going to do is ask SolidWorks to do that in just a second. First of all, I'm going to come up to my options, and hopefully you'll all be familiar with the document properties. So these are settings that identify with solely the part, so the file that you've got open at the time. And so you'll see at the bottom here we've got Dimxpert options. So I can choose whether to use my general tolerance or my block tolerance just here, and I can go through and specify some for my size dimensions. I can specify my diameter, my length slot, etc., etc. So for example, for my diameter, I'm actually just going to change this to a bilateral, and I'm going to put 0.85 just so that we can see that later on, and a minus 0.15 just there. Again, we've got something similar for our location dimension. You can also specify how they are dimensioned up. So we could specify for an inclined plane, just the two normal planes, that's the one I'm after, or we can specify one of the normal dimensions and the angle. Chain dimensions, so if we've got, for example, hole patterns, then you'll see as we go through this menu, everything is quite nicely highlighted for us, so it's not trying to figure out too much. It's all on the screen, so you can figure it out on your own. Geometric tolerance, so here is where we can choose what's going to go in that feature control frame. So for example, here for the position, I'm going to make that 0.65, just so that we can see that when it comes up on the screen. And chamfer controls, so we can choose how SolidWorks not only tolerances the chamfer, but we can also choose how it recognizes the chamfer. So we might have large angular planes which we don't want SolidWorks to recognize as a chamfer. So as long as it doesn't fall within this setting, then SolidWorks will just assume that it's an angular plane and continue as normal without applying the chamfer tolerances to it. And finally, our display options, which is again more options for how, say for example, the slots are dimensioned, whether it is like you see on the screen here, or just two linear dimensions for the length and the width. Okay, so let's just hit OK there and start setting up our automatic scheme now. So I'm going to hit the automatic button and we get the automatic feature manager. So we can first of all specify the part type. So what I've got here is something that's probably more turned than prismatic. So prismatic is something that perhaps you might just be milling. Here we've got a turned part. So I'm going to stick with that termed option. And we can specify the tolerance type, so we can stick with that coordinate tolerancing system or the plus-minus scheme that a lot of people do use. You can do so in here, and we can in actual fact specify whether we want the pattern dimensions to be polar or linear because we have chosen a turned part. Here I'm going to use the geometric system, and then SolidWorks will prompt us to specify our datums. So I'm going to use this front plane as my first datum. For my second datum, I'm going to use this internal face here on this diameter. And then finally, for my third datum, I'm going to choose this notch just here. We can specify whether we want the tool to go and tolerance all of the features or specific selected features. And we can also specify which features we want it to recognize or ignore. So for the time being, I'm going to leave it doing all the features and picking up every feature that is available. I'm going to hit OK. And you'll see SolidWorks is going to whip through. The part's automatically gone green because everything has been fully toleranced, and you'll see SolidWorks has added all of the tolerances and our geometric feature control frames without us having to do anything. And so you'll see here our positional tolerance has picked up that 0.65 that I asked it to. Our diameters have picked up that 0.85 and 0.15 that I asked it to also. You'll also see that it's added the datum annotations to each of my datum selections, and you'll see how significantly quicker that process was, and I haven't really had to add too much detail apart from setting up the part originally, but obviously once you've set up your scheme that is done and dusted for you, so you won't ever have to touch it again. But if, say for example, I've got a special case where this particular component is different to everything else that I've set up so far, it's very simple to change. All I need to do is select it, and I can come in and change that, say, to a 0.65 over here, and you'll see it'll update for me. Likewise, I can do exactly the same with my feature control frame. I can change that to a 0.15 in here, and it'll update for me. And as we saw before, I can just drag all of these tolerances straight over into my drawing with no problem at all. Okay, that's a very quick lowdown on using the Dimxpert tool. Like I said, we do also have the opportunity to include tolerance analyses for our assemblies, so we might see that later on, but what that's going to do is take into account all of the tolerances that we've placed in here, and then it's going to use those in a stack-up analysis. Alright, so thank you for joining me. Let's put that slide up. Please do remember that this has been recorded, so this will be going online sometime soon, so you'll be able to go back and watch this whenever you like. All right, and please do drop by for our future webinars. Next week we've got SolidWorks Design Checker coming up, so that'll be same time next week. I think that's about it. So if you do want to get in touch, you can drop by our website, which is on your screen. You can email the support address. That'll come through to the tech support guys at Innova. Or you can give us a call on the phone number that you see on your screen now. All right, thank you for joining me. Take care and see you soon.